Hello everyone, we're back with another episode of I Build at 4 a.m. and this time is for our series 3. It's called Brain to Board. Differently from the other series, right now we'll have a more interactive session where we can have board drawings and deeper understanding of the architecture of the solutions that we here discuss. For this episode, I have accompanying me Mayur, the founder for Arcana. Hi Mayur, how are you?
Hey, João, I'm doing well. How are you?
I'm very good, man. It's a beautiful day in Lisbon. I'm very happy to be back home after festivities. So today we're going to talk about many different things, but I want to start with Arcana and your chain abstraction, right? From what I understand, correct me if I'm wrong, it's chain abstraction, not wallet, not account abstraction. It's the full abstraction that you don't even need to know the chain you're using or where the application is running on, and assets are already handled, bridges and portals, everything is put together in a nice way for the developer, correct?
So, yeah, that's pretty much like a succinct definition.
You do have also other products, right? I think this is a good moment to talk a little bit about everything you do in Arcana. If you want to introduce yourself and what you guys do.
Yeah, sure. I'm Mayur. I'm the founder and CEO here at Arcana. At Arcana, we basically like to say that we are in the business of abstractions. It's our strong suit. It's basically taking the complex bits and hiding them away, even from the developers and, of course, the users. And this we feel is something that is very necessary for the ecosystem at large. To this effect, the first product that we actually launched was like a wallet abstraction product. It's called Arcana Auth. What it does is basically any app that integrates this, the Arcana Auth SDK, can allow the users to basically sort of do like Web2 logins, email, social accounts, those sorts of things. And the Arcana Network gives these users a non-custodial wallet right inside the app. So you're basically abstracting away the complexities that come with, private keys, seed phrases, installing third-party wallets, so on and so forth. And from there, we went on to kind of do the next thing, which is sort of like, which is gas abstraction, which is basically based on the account abstraction ERC4337, which basically allowed developers to sponsor gas fees on behalf of their users. So with these two products, what we effectively managed was getting the user from the landing page to homepage through like the auth product, through a sign-in sort of. And then from, say, the homepage to the checkout page by allowing them to interact with the app through gas sponsorships. And once we kind of went down this journey of getting users from landing page to homepage to checkout, the point was now to kind of try and figure out how do you make it easy for users to spend, right, to actually perform the checkout. And we started to see that there was a lot of growing troubles when it came to users needing to have to like bridge assets from many different chains onto the chain that they actually wanted to spend their money on. And this would be like an ever-growing problem given not only Ethereum's modular thesis, but also the general fact that we are now well and truly going into like a multi-chain world with all the different rollups, alt VMs, alt L1s, and all of these sorts of ecosystems that are going to like really flourish over the next couple of years.
I mean, the ecosystem is spreading. We are having many chains. We're having many layer 2s, many rollups. Anything you can think of, we have many of them right now, right? So how does chain abstraction itself plays a part on unlocking the potential for mass adoption of Web3?
Yeah, so mass adoption right now is like a meme in the space, right? So we talk about how our industry does well, especially during bull market cycles and things like that. But the users actually entering the space is a trickle compared to what it ought to be. And this is something that, is, you could regard it to be the holy grail, but it has become a bit of an inside joke now that really there aren't very many real users. And you could attribute this problem to to many things. A lot of people, especially the non-believers, will basically say that there is no use case for blockchains. There is no use case for crypto outside of pure speculation. And this is something that a lot of different projects have done. Have basically in the last couple of years, especially, have come in and shown that it's actually possible to kind of build alternate versions, more trustless, more decentralized versions of Web2 applications, whether these are games, whether these are social media applications, and so on and so forth. So but where there is definitely like friction is, I would say, on the user experience side. Like, for example, if someone came to you and, let's say for a second, João, that you are not crypto native, and told you about something very interesting that you should try out, say something like, say, a Farcaster, or maybe even go ahead and buy a meme coin that's going to suddenly 100x in the very near future. These are all very interesting things for the general public, almost all internet savvy users. But the whole process starts with first explaining what wallets are. Then it goes on to explaining, what private keys are, seed phrases are, saving these things. Then how do you procure gas tokens to be able to buy these sorts of assets, and on-ramping from fiat to crypto, and then actually going ahead and doing all of these sorts of things. And so this places massive friction. And it's not as simple as someone telling me, did you check out this new website, which is just, say, like a Web2 app or a SaaS platform or whatever it may be. And I just go log in and I'm quickly able to start experiencing it. So this causes massive churn at the user level. And I would say, is probably one of the biggest reasons for a lack of sustainably large adoption of Web3 in general. And all the different kinds of abstractions that a lot of different teams have been doing great jobs with are only going to help in fixing this. But I think the missing link here is the chain abstraction bit, which is going to change the paradigm fundamentally to make everything more app centric and app focused. And the idea behind it is that users shouldn't have to worry about where an app is deployed or built. They shouldn't worry about where they hold assets currently. And they should be able to kind of use these applications irrespective of where their funds are or where that app is actually built. A simple example of this could be, I have, say, stable coins on Optimism, Arbitrum, and all these different chains. But I wanted to buy a meme coin on Solana, on Radium on Solana. And there is no way for me to do it unless I bridge all my assets over. And this needs to go away. And the best way that we know how to do this is currently just bridges, right? So I have to go to a bridge interface, one by one, bridge all these different assets over, make sure I have the gas tokens to be able to pay for it, and then figure out these amounts that I need, etc., etc. And this is exactly what chain abstraction solves. Our definition of chain abstraction is quite simple. It really is about unifying a user's asset balances across different chains and allowing the user to spend these unified balances on any other chain almost instantly without needing to actually explicitly bridge. And if you are able to kind of make this happen, then you are engaging in chain abstraction and you are basically improving the user experience.
No, so you touched in a point that I think it's very relevant, which is how the developers have to think about how bridges work, how everything is so complex. And I think that the user experience is deeply tied to developer experience, right? At least here in Cartesi, we think so. And we see how when we improved the DevX, every single time the use cases get so much better because the developer does not have to worry about so many things, right? At least this is one effect I see. I would like for you to tell me what are some of the downstream effects or ramifications that you foresee from chain abstraction, and if chain abstraction takes off like as expected, right?
Yeah, so I have some pretty strong views on this point. I feel that chain abstraction will take off almost exactly like how people building in the space are predicting it. The timelines may vary. It may not be as immediate as some people say it will be. But fundamentally, what happens is that if you are able to allow the user to unify their asset balances across different chains and spend it on any different chain, basically give them one balance and let them spend it almost instantly, what you've created is a massive, like 10x jump in the user experience. And while on the face of it, this is great, and if people think of it as just a mere UX improvement, the thing is, any sort of like 10x improvement almost anywhere in the stack can have severe ramifications in general. And if we kind of go down this rabbit hole of what happens when you enable something like this, the first thing is obviously the user experience improves. So you have the potential for people being onboarded on a much larger scale on a day-to-day basis. What changes downstream of that is the developer experience and how developers sort of like work now compared to the status quo that exists. Fundamentally, if you've seen what has happened in the past, right, is that some of the biggest protocols in the space, be it Uniswap or Aave or anyone else, have seen their code being forked and just deployed on any new chain that launches. And what happens is, and the reason this happens is that fundamentally almost all these new chains require a new, almost the same, not new, sorry, almost the same sort of DeFi primitives to exist on their chain. And if, for example, someone launches a new chain tomorrow, they want to have a DEX on the chain, they want to have a lending borrowing protocol on the chain, they want to have like a perp DEX on the chain, and basically what you're doing is rinse and repeat. Someone will go and fork one of the existing code bases and just go and deploy on this chain because it does not exist on that chain. And that's the only reason, right? And which is why what you're seeing right now is some of the protocols, like most of the protocols that do well for themselves and build a big enough name, reputation, have great traction, users, revenues, and all of those sorts of things, are almost forced into deploying on all the new chains that are doing well. And so what you then end up with is basically instances of the same protocol or the same app on all these different chains. And now you're basically going to be doing a lot more DevOps than actual engineering or actual concentrating on features that improve or solve novel use cases or do actual real innovation. This has been like the bane of our industry because I think people think in this sort of way where, let's say a new chain is launching tomorrow, that chain is going to somehow bootstrap some sort of liquidity by basically doing some sort of incentive programs, promising airdrops and all of those sorts of things. And so everyone wants to kind of go and sort of build there, and then the airdrop happens and then everything just dies down, right? All your TVL basically sees this massive drop. And these sort of like TVL games need to like stop happening because it's a net negative, in my opinion. There is no new innovation and all of these sorts of things need to change. With chain abstraction, what you can do is, as a developer, actually build on any platform or on any chain that you already like, or even deploy your own chain, a brand new rollup or a brand new L1 or a brand new app chain, or you're just deploying on whatever chain suits your app's business and technology requirements. And users can come with funds from almost any ecosystem and spend it with you, right? So from like a user standpoint, you really don't have to go and build multi-chain trying to, go chase users where they are, so to say. The idea is you flip the whole script and let the users come to you, right? So now what this enables is that you will build multi-chain features that require bridging or just general message passing only if it improves the lives of your users, only if it adds a new feature. not because you just need to be present on all these different chains. So that, I think, is like one of the bigger downstream effects that will come into play. And I think further beyond that, further downstream, is the effect it will have on chains and chain ecosystems. Because if developers are going to simply pick chains that suit their requirement based on whatever apps or protocols that they're building, then you're going to start seeing a massive decline in usage of, the general purpose sort of, say, layer 2s or chains that don't really have a great differentiator. Like if you have very high TPS, like say 10x of whatever exists on existing chains, then you're probably going to do well. If you have privacy built into your chain, then you're probably going to, attract certain set of use cases. But if you're just another that is doing exactly the same thing that some of the more established L2s, the incumbents, are already doing, then you're probably not going to make it. Because there is no real incentive for someone to build on your chain. There is no real incentive for anyone to kind of go and transact and bring liquidity to that particular chain. So this is going to mean like a massive, almost dimensional shift in the way people approach chains. I think chains are going to get rendered to becoming basically like how AWS, GCP, and are treated on the whole stack as pure base layer infrastructure. And their unique features that they offer to applications and developers is what is going to make them stand out and get used more and more. The rest are really going to fall by the wayside.
Perfect. This is a very nice answer, man. I think it's a great opportunity for us to have a better insight on how everything could work if we could open now the whiteboard and see a little bit of how the data flow and how the infrastructure, the architecture of Arcana works in the backend.
Yeah, sure. So I'll just go ahead and share my screen. I hope you can see it.
Yeah, we can see it right here.
Cool. So the way that Arcana works and the way we've sort of designed it is basically it's an intent solver based model, and I'll talk a bit more about that. But fundamentally, at the center of everything, what we have here is the Arcana Network, which is basically like a Cosmos-based app chain. And this is what we use. You can think of it as basically like a state machine that's keeping state and is the source of truth for everything that's happening within the Arcana network and what the protocol does. It is also essentially what basically keeps track and orchestrates everything that's going to happen. What you have on basically like the front end is let's say any sort of app, and let's say this is an app, and let's say it is built on chain B. And so what we do is this app basically integrates with the Arcana chain abstraction SDK. So this is what we have so far. You have an app built here, and it integrates with the SDK. The SDK is basically like this gateway between, these two, between the app and the protocol itself. What we further do is that we have these sort of like what are called Arcana vaults, which are essentially escrow contracts. And these are deployed on every chain that the Arcana network supports. So, for example, right now we support Ethereum, Arbitrum, Optimism, Base, and Polygon, and we have these escrow contracts deployed everywhere. So fundamentally, what we have is two sides, let's say chain A, and we have chain B, and we have these escrow contracts on basically both sides. And we have this app here that's built on this particular chain here, and it interacts with this. So now what basically happens is that the user is going to connect their wallet to this app. This is the user wallet. Let's say it's MetaMask, Rabby, Phantom, anything. And now what we also have is the solver network. So we have the Arcana solver network. Basically, it's a collection of nodes run by individuals or entities. All right, so this is the lay of the land. So we have two different chains here, chain A, chain B. We have the Arcana vaults, which are escrow contracts deployed on these different chains. Essentially what you have is an app that is built on chain B. It integrates the Arcana chain abstraction SDK, which is the gateway to the entire protocol. And the user comes to this app and basically connects their wallet to this app and now starts using it. So what the chain abstraction SDK enables first and foremost is that, so typically when you were to basically connect your wallet, let's say your wallet is 0x123. And what this will tell you is the first thing you need to then do is basically you would have picked a particular chain that you're on. Let's say you are on Arbitrum. And this will tell you, what sort of balances you have on this particular chain. So let's say you have USDC, about 10 USDC, and let's say you have USDT, another 10 on this chain. And then you are able to kind of, basically spend these balances. But now with the SDK integrated, this changes from being just Arbitrum, it becomes already multi-chain, supporting all the different chains that the Arcana network supports. And now we start to unify your balances across all the different chains. So let's say you had more USDC on other chains. You will now see a USDC, but you will see now a chain abstracted balance for USDC. Same with USDT. Instead of seeing 10, you're probably seeing 100. And this is what apps are able to now show users. A chain abstracted balance instead of showing just balance on one particular chain. And then what this basically enables is the user to be able to kind of spend this balance. So let's try and kind of provide what the actual breakdown is, right? So let's say this user has on chain a USDC of say 25 and USDT of 50, and the breakup is on chain B is the same. But the user now has this combined balance and actually able to spend this combined balance, and we'll talk about how that happens. So when a user wants to be able to spend more than what they have on one particular chain, let's say the user wants to spend 40 USDC instead of just the 25 that they have on chain A, on chain B rather, then all they need to do is to express that intent, and this is what Arcana enables. So their intent is basically going to be something like saying, I want to spend 40 USDC on chain B. I have 25 USDC on chain B, but have 15 more on chain A. And so this is the intent they express, and this intent is what gets submitted to the Arcana app chain. And once that gets submitted, it is what the network is actually confirming that the user actually has these balances. And then what happens is that the user will now be able to, what it proceeds to do is actually start to collect these balances that the user has on chain A and move these funds from their wallet to the escrow contract. So this will take 15 USDC from this user's wallet on chain A and place it in escrow. And once that happens, the next step is that this deposit of 15 USDC gets conveyed to the network of solvers that the Arcana network, the protocol has. So it'll say 15 USDC collected, and basically once this event is emitted and the solver nodes confirm that indeed the 15 USDC was deposited by the user, now the user cannot double spend this money. It's already placed in a contract. So now the solvers are actually free to go ahead and supply the liquidity that the user is missing on chain B to basically take their balance from 25 to 40. So what happens is that all of these solvers get into a race to basically fill this order. So they're all looking to fill 15 USDC that the user is missing on chain B. And this basically goes through the contract and down back into the user's wallet. And at this point is where the user receives 15 USDC on chain B.
So this
and
is
once
very
this is
sorry, just to make a very small question right here. This is very interesting because the way escrow contracts work and allowances work, you are able to actually fill the amount of tokens that user needs for that transaction in the original chain, right? You're not passing it through some other user, so it ends up being the exact same transaction as if that user always had those tokens on that chain, right?
Exactly. That's precisely it. So as soon as this user receives this 15 USDC into their wallet, their balance is 25 plus 15 USDC. And basically their spend that they wanted to do on this app is now possible. And all of this basically happens in a matter of seconds, everything from collection to fills. Now, there is definitely scope for improving this and making this more efficient and more faster. And this is what we're looking at right now, different ways in which that can happen. But typically, this takes anywhere between 15 to 20 seconds. And you could also basically do multiple sources, right? So similarly, the user could have had funds on chain A and chain C and combined those balances to basically be able to supply more. So let's say if basically the user had 25 more USDC and wanted to spend, let's say 60, so it'll collect say 15 USDC from their chain A balance and will collect another 20 USDC over here. So you can actually do multiple collections. So multiple inputs, but one output. So instead of 15 USDC, now you're going to be basically supplying 35.
This makes it so very clear, man. It's amazing. And I think it's a really neat design because what it happens, it really abstracts all the transaction. It does not fake it. It does not just create a level on top of it that simulates it or emulates it. You are actually doing the full transaction. And this empowers us to have such nice development on top of this here. I keep looking at the app, and the app is an app itself, right? It just has a compatibility with the SDK, but it doesn't have to be built in a very specific way. So like when I was testing myself, I could actually use all of this solution and simply create a Cartesi app here. So I could simply create an app chain. And that was really nice for me, right? This was basically me being able to deploy one app from Cartesi on top of many different networks at the same time, because I could transact it from anywhere I wanted. So this was really nice. I'm gonna even remove it from here so we can just see our architecture. But it's really cool to think that this can be done.
Yeah, no. If you think about it, like this exists in the Web2 space. Like when you do international remittances nowadays, you now have the option to do this in the form of like with companies like TransferWise and all of these other guys. What they're essentially doing is, collecting funds from you on one side and in your, say, your home country. Let's say I live in UAE, but I need to send you some money in Portugal. Then basically what they do is they collect UAE dirhams from me and they keep it in a local bank in the UAE. Then the local bank basically contacts another local bank in Portugal, and you're going to get the money that I sent you almost instantly. So as soon as this deposit is confirmed, you are going to go ahead and receive this. So this design and model is not novel. It's existed. Now it's how do you bring this to a place like blockchain and crypto in general. And the complexity, I think, starts to come when you want to do multiple inputs, right, with different currencies. So obviously, the idea is that how do you do like multiple inputs, but also, let's say I have USDC, but I wanted to spend, say, Sol. Then how do you make that happen? So these are some of the improvements that that I sort of was talking about earlier, which will actually, really start to empower users and developers. Like you can build an app on Solana, but you can get users to spend their Ethereum or EVM native sort of like assets almost instantly. And this is what, if we enable them, it starts to become like the Web2 world, where I can sit in any country and buy goods from China without having to, do conversions and have local bank accounts in that country. All of that stuff is just ridiculous to think of in like the Web2 world. And that's what we should make happen in the Web3 space.
One other thing that I wanted to check with you is, like, in all of this design, in all of this solution, what are some of the trade-offs that you found? Like, was there anything that you had to sacrifice in pro of building all of that?
Yeah. So one of the ways, there are a couple of trade-offs and a couple of very key design choices. We try to remain extremely pragmatic. So as you can see here, the first thing that I will talk about is the trade-off of actually building this entire thing, right? So as you can see, we're pretty much full stack. Like all you need to do is integrate one SDK and everything we sort of built and we make happen. Chain abstraction actually exists on, I would say, 3 different layers. One is at the account level, basically, being able to show this sort of chain abstracted balance. Then the other is more of a middleware orchestration level, sort of what the Arcana app chain does. You basically are saying, collect these funds from these places, supply these funds on these places, and so the user can actually do what they want to do. So user expresses an intent, that intent gets, how do you fulfill it? So what is the chain of like actions that need to be orchestrated in a particular order to make this happen, right? So in our case, we are orchestrating the collection of 15 and 20 USDC on chains A and C to be able to supply 35 USDC on B. And the third level is basically the solver network, like who is going to supply this liquidity. There are multiple ways you could do this. You could use existing bridges. You could use a solver network like how we built, or you could basically perhaps even build this on the back of some sort of like novel AMM design. And all of that is possible. And we actually kind of ended up building across the entire stack because there are multiple reasons. One is the simplest reason was we wanted to build all of these things, and we would be happy to work with people who have already built this stuff, but it didn't exist, at least not in production. And we didn't want to kind of wait around for other people to kind of build their stuff out. So we went ahead and basically built it. The other thing is value accrual. Like, where does value accrue in this entire stack, right? You have these 3 different layers. Some people will tell you it accrues closest to the order flow. So if you're on the account level, then you're very likely to accrue the most value in a chain abstraction stack. Some people will say that the actual orchestration is what brings the efficiency, and that's where value accrues. And some people say the closer you are to the money is where value will accrue the most. So honestly, this will get answered only over time. Everyone just can make like good estimates and guesses at this point. But so we felt like, building all these pieces, especially given the fact that we had the capability, we thought that would be the best way to go about it. So that was one of the things that we kind of said we'd do. The other big thing that I quickly want to touch upon is this other big trade-off. Actually, our design was based on account abstraction, ERC 4337. So right now, what you see is this app here where the user connects a wallet, and we are collecting funds in these different escrow contracts. But these escrow contracts could basically have been like a account abstraction, like smart account, right? And like a smart contract account. It could have been that, where basically you're depositing funds into this account, and now the funds are sitting here. And what you do is, if the user wanted to spend funds from this, then you have some sort of like resource lock mechanism where basically the user cannot spend funds until and unless, like, let's say a third party signs off on it and says that they can spend funds. The thing about a resource lock is what it enables is that you don't have to now wait for the collections to happen before a solver fills the order or fulfills this intent that the user has. You can just go ahead and optimistically fill the order because you are certain that those funds will not be moved. And we felt like initially that this was a great design. It would help us literally halve the time it takes right now. Right now it takes about 15 to 20 seconds. You could bring that down easily to 8 to 10 seconds. But the big problem we saw was that the thing with account abstraction and smart accounts is that there's so few of them for there to be like mass adoption of it. And the most important point is that nobody has a smart account which is fragmented. Everyone has a MetaMask EOA or a Rabi wallet that has funds fragmented across different chains. Almost everyone has that. And if you are going to connect your fragmented balances and going to transfer them into an SCA first, then your funds are no longer fragmented because you can just choose what sort of transfer you want to do. So if you're going to put in that effort, then it's very likely that you can go the extra mile and actually not have fragmented balances in the first place. So we made the very clear choice of supporting EOAs first, even though it's going to take this extra time to do all of these collections and actually induce the resource lock. We felt that it would still be a better idea because that solves a real problem for today.
One other thing that looking at the architecture here, I bring myself to question is in terms of scalability and adapting to other types of assets, other types of tokens, escrow contracts, everything. I kind of can compare it a little bit to what we do in Cartesi, where we have our framework contracts deployed in a chain, and from there people can start deploying their app chains on top of that chain, right? So what we did as a fully open source project was simply enable all these contracts for users to deploy them, and they are able to start using Cartesi independently of us in any EVM compatible chain, right? How do you see the scalability in terms of allowing and adding this Arcana Vault escrow contracts to other chains? And how do you see, do you have any plans to allow users to do that themselves? What is probably the best process to make this more scalable in the huge universe of chains and L2s that are coming on and on more and more?
Yeah, so that's a great question. I think scaling this is the big thing that most chain abstraction projects need to kind of answer for. The point is that almost all of us who are building in this space can perhaps in our own different sort of design and different model support all, like, say, the top blue chip chains, support all the top blue chip assets, all your stable coins and ETH and this and that. And yeah, sure, that probably is the majority of all usage in crypto today. But like I said right at the beginning, I think we are entering a truly multi-chain future. You guys at Cartesi are doing a great job in advancing that future and making it happen sooner. And I think we need to get to a place where, if someone deploys an app chain and has their own asset on their chain, they shouldn't have to require a user to go to an exchange and buy their token to be able to use their app on their app chain. The user should be able to come and just spend USDC that they have on, say, Optimism to basically almost indirectly spend the native asset that this app chain has. And that's what we should enable. And the way I think we can make that happen is, I think our design sort of lends itself to that, in the sense that it could very easily be something that the community tomorrow just adopts. Vaults can serve as like the precursor, but it's a very simple design. They do just a basic set of things that needs to just become, like, say, for example, a Solana contract tomorrow, or say like a Sui contract in the move ecosystem tomorrow. This is something almost anyone can easily build, just deploy. And I think the key part is actually making the assets available and democratizing this solver network sort of infrastructure. I say that because what happens right now is that all the major bridge providers are really not going to touch these small app chains or very niche app chains that people launch. It's either going to be cost prohibitive, or it's going to take too much time for support, or support may never come in the form of these sort of bridging providers. But with this sort of like a solver design, that can scale very easily, because all you need is basically a bunch of holders of that particular token. Let's say it's the foundation themselves, or perhaps a few early investors who hold tokens, who can actually come and become a solver within the network and provide that route, where they're saying, I will accept USDC on, say, Arbitrum, Optimism, and Base, and supply this sort of like niche native asset on this app chain. And I will supply, basically, I'm opening up this route, and I will open up the reverse route that is basically going from this niche asset back to USDC on Arbitrum. And as long as you do that, you can easily scale this up to support almost any asset on any app chain.
This is amazing. This is something that we've seen so many discussions in DevCon, for example, about interop, and this is really a big tackle in that direction, right?
Yeah,
I really like to see it.
Yeah. So yeah, I think what happens a lot is, and this is my personal opinion, is that a lot of the interop that we talk about ends up getting like overly technical, while it can actually be done more simply and pragmatically with reasonable trade-offs. And trade-offs exist, no doubt about it. But I think, there is this tendency to nerd out on solutions and build the most technologically advanced solution. Whereas, sometimes all you need is something that is just operationally just efficient and just works.
That's perfect. I think that's a great way to put it. I wanted to have another teeny tiny block right now here in the podcast, which is the rapid fire. I don't know if you're familiar with it, but I'm going to throw some questions at you real fast.
Okay.
And you have to give me answers like very short, like one word or one sentence, and without thinking too much, right? Okay, ready?
Yeah, sure.
If you could choose any superpower, what would it be?
Time travel.
Time travel, nice. What's your best productivity hack?
Productivity hack.
You cannot say time travel. Sorry?
Waking up early.
Waking up early. What's your favorite Web3 use case so far?
Or DeFi.
And if you had the opportunity to work together with some protocol, which one would it be?
I'm going to say Uniswap.
Uniswap, nice. Who's your reference in the space? One person?
This is a bit of a cliche, but Vitalik.
Fair. I mean, it's for everyone. And one piece of advice you would give your younger self when starting in blockchain?
Younger self. Yeah, don't sell your Bitcoin at $1,000.
I think that's a very good advice, honestly. Now, back to the regular questions. Something that I would really like to hear from you is, what are some of the future innovations and trends in general Web3 that you find interesting, and some that Arcana is preparing to contributing to, or anything that you think is worth paying attention to?
Yeah, there are a couple of things. I think in the immediate term, the thing that we are quite excited about and actually looking forward to is EIP7702, just in the Ethereum ecosystem. We've had major issues with how 4337 was rolled out. I think account abstraction as an idea is great. It is very much necessary, but I think we were in too much of a hurry and everyone just got onto the account abstraction hype and didn't really care to think too much deeply about how to execute like solutions and some of this middleware that got built out, where despite the idea being so great, we are now ended up with many problems with the way like smart contract wallets are built and deployed and used today, and which has prompted basically multiple other EIPs to have to come in, and finally now we have 7702, which does most of what account abstraction sort of like promised. And I think it's a great thing where basically your EOA converts on the fly into like a smart contract account. Now you can do gas sponsorships, you can do batching of transactions. This is all great stuff. This is what the Ethereum ecosystem desperately needs. But I truly hope that people don't mess up this time and the trade-offs are well understood. I think there are certain like security implications, but hopefully we have like very pragmatic solutions to these and we don't end up in the same place that we did like 2 years ago with account abstraction. The other thing is probably slightly more long-term, and that what we are very excited about is generally AI and AI agents. Of course, it's such a huge narrative within the space, but I think just the idea that AI agents will interact with humans and AI agents will interact with each other and other protocols and things like that, and will probably do autonomously perform actions and do different sorts of things. I think one of the primary actions within the crypto space will be actually spending monies. And I think we are basically preparing for a future where even whether it's human or AI, everyone needs chain abstraction so that you can basically unify your asset balances, just keep spending irrespective of what the destination protocol or AI agent requires on their end. You just have money, they want money, you're spending money. That's it.
Yeah, of course. I love the take. I mean, AI for Cartesi, it's at least such a big thing. Being able to run models verifiably on chain, it's crazy for us. Yeah. It's all the hype that we want to see happening. But I also love the inputs you gave about account abstraction. I do think it's a big deal, and I love something that you mentioned, that the way you tackled the whole infrastructure for chain abstraction was on top of account abstraction in some sort of way, right? I think this is a great showcase of how, if you pick something that already exists, you can build on top of it and make it work seamlessly with other things without having to think too much, right? In our case, was picking the EVM as the entry point for our rollups. For you, it was getting account abstraction. And even though these things can be changed and can be moved, it's a huge way to improve your developer experience, improve your user experience, and improve the whole ecosystem. Mayur, I think we're going to have to wrap up now because we're running out of time, but I would love to hear any final thoughts or messages for the Web3 community and our listeners that you want to send.
Yeah, no, first of all, thanks for having me here and giving us the platform to be able to kind of speak about a topic that's very close to my heart personally, and of course, something that we are extremely excited about at Arcana, and talk to you guys a bit more about the inner workings. Generally speaking, I think this space requires many more builders, many more innovators, and I think there is enough work happening to ensure that their hands are not tied, and people having to kind of repeat the same sort of builder thinking that has existed so far in the crypto space. And now finally they'll have the tools and the infrastructure to be able to kind of build apps, protocols, whatever they want to. And really build new innovative use cases within the space. Because I think that's something that this entire industry has been chided for not being able to produce outside of DeFi. I think it's time that we start attracting all of these people. So people like you, people helping people build out their own infrastructure, people like us helping people hide complexities. I think all of the stuff is available, and people need to start now building really innovative stuff. And I'm looking forward to the next couple of years.
Yeah, man, thank you so much. Can't say better. Thank you for coming. It was a pleasure talking to you. I learned so much in here. So yeah, that was it. That's iBuilder 4 AM. Keep building and pioneering the world of Web3. Bye-bye.